I love problems like this. They're so much fun. They're like logic puzzles you have to work through. Even if you don't get it right the first try, it's really fun to keep going and trying to gather as much information as you can to make the best possible guess. In this case, the answer I was looking for is 1/6 or 1 out of 6. You might have also had 0.16 repeating or something around 16.6% repeating, something like that. Fractions are easier to deal with here, so let's try to work with that. Well, let's think about this for a second. We know it's an autosomal recessive pedigree. So if that's true, it means males and females are affected equally because this is on an autosome somewhere. This affected male here, this must mean that he is homozygous recessive. If he's homozygous recessive, we know that his parents had at least one recessive copy apiece because he would have had to have gotten both of his copies from his parents. Well, they must have a recessive copy, but they're not affected. This means they must have a dominant normal copy here. So his parents must be heterozygous. We figured all that out already. So now let's look at his siblings. We know they're not affected, so they're not minus minus, but they could be either plus plus or plus minus, right? So there are two options here. Let's focus on this female because this female is involved in the reproductive event here. So to figure out what the probability is that this individual is heterozygous, because that's the only way that they could pass this allele on and have an affected child, is we got to figure out the probability of this individual being heterozygous. We're going to do the Punnett squares of the parents, right? If the mom and dad here are both hets, then we could either have a plus plus, a plus minus, or a minus minus. Now we know already it can't be minus minus, so let's get rid of that option right there. That gives us three options left. 2 out of 3 of those are the het. So we're going to say she's a 2/3 probability of being heterozygous. Now let's do the same thing over here. We know that the mother is affected, which means that she's homozygous recessive, in the same way that we figured that out over here. Her son is unaffected. So that means he must have at least one normal dominant copy, but he must also have one recessive copy because the mother only had a recessive copy to give. So he must be heterozygous. That's a probability of 1 that he's heterozygous. Now, if he's heterozygous and the person he's mating with is also heterozygous, set up their Punnett squares. They could have a plus plus, a plus minus, or a minus minus. Only one of these cases is an affected individual, the homozygous recessive, so that's 1 in 4. So now what we have to do is multiply all our probabilities together. We don't add them, we multiply them. So the probability that this guy is heterozygous is 1. So we do 1. The probability that the mother is heterozygous is 2/3. And the probability that they'll actually have an offspring that's affected is 1/4. So this would be 2 over 12, which is equal to 1 over 6. Now, that's a simple one. Imagine if I gave you a hard one. Hopefully you'll have a little more respect for those genetic counselors.